Hello everyone. Today I'll be discussing a topic called performance rating. So we have already seen what is meant by performance rating in the previous lectures. It is the same concept which you will be using here as well. So performance rating is the process of comparing the performance of the operator. So the performance of the operator is compared, that is the observed performance is compared with the normal performance. So mathematically you can say that it is the ratio of observed performance to the normal performance. We already saw this idea in the previous lecture. Hope the idea is clear. And in today's lecture, we will be understanding the kind of performance ratings which you will be using. So the first kind of rating is called the speed rating. So in the speed rating, what is being considered is the speed or the pace with which the worker does his job. So the speed rating consists of comparing the speed or pace of the operator working in relation to the normal pace. So the actual pace is compared with the normal pace, and you get a factor when the comparison is done. For example, if the worker is having a rating of 125, it means that the speed is 25% higher than the normal pace. So that is meant by speed rating. The next kind of performance rating is called the synthetic rating. In the synthetic rating, what you do is, in this method, the performance rating is established by comparing observed time of some of the manual elements. So this thing should be very clear. It is clearly said manual elements with those of non-time values of the elements from the predetermined motion and time studies. Hope you remember this term. This term was very clearly explained in the previous lecture. So after doing this study, you will get some predetermined values, and that is actually compared with the actual value. So this is basically the ratio of predetermined time for elements and average actual time value for the same elements. So one thing which you will have to keep in mind is that you only consider manual elements in this particular method. To understand the concept better, let us take an example. So in this example, you have a table which shows the number of elements, that is 1, 2, 3, 4, 5, 6 up to 8, and the type of the element. So M represent it is a manual element, and P represent it is a machine power element. Okay, and the actual time, that is the observed time for doing that particular work, that is 0.14, or that particular motion, that is 0.14, 0.16, etc. And now you have the PMTS values for doing, say for example, you are just considering 3 elements here, that is element number 2, element number 5, and element number 8. So these are the standard values for completing element number 2, and this is for element number 5, and this is for element number 8. So you know how to find the rating. The rating is actually what? The rating is the ratio of the PMTS value divided by the actual value. So for the element number 2, R2 can be written as 0.145 divided by the actual value. What is the actual value of element 2? The actual value of element 2 is 0.16. So you write 0.16 and you find out the ratio. So the value comes to be something around 90.62 percentage. Similarly, you find out the rating for what is the next element which you will have to look into. You are just considering 3 elements as I told you, that is element number 2, element number 5 and element number 8. So you have to find out the rating for all the 3. So R5 is the ratio of the non-performance, that is 0.255 or the PMTS value, divided by 0.26. So that comes to something around 98.08 percentage. And similarly, R8 is equal to 0.145 divided by 0.15. So that comes to something around 96.66 percentage. So you got the individual rating for all the components. Now you will have to find the average of all these ratings. So our average will comes to, that is the average of 90.62, 98.08 and 96.66. So the value is something around 95.12. So I will approximate it to something around 95. So this is the average rating. Now what you have to find usually in the problem is the normal rating or the normal time. So the in order to calculate the normal time, if you have the average rating, the normal time can be calculated by just multiplying the average rating into with the average actual time. So here you have a lot of individual elements which are present. So you will have to sum up all the times, that is 0.14, 0.16, 0.52, 0.26, 0.45, 0.34 and 0.15. So you will have to sum up all the elements. I just took all the elements except 3. Why did I do that? Because 3 is machine powered, the other ones are manual elements. So in this particular rating, which element do you consider? You consider only manual elements. That is very important when you are doing this particular problem. Okay, so you just consider 95% for the manual elements. So you will have to sum up the time for the manual elements like 0.14, 0.16, 0.52, 0.26, 0.45, 0.34 and 0.15. And for the machine powered element, you consider an efficiency of 100%. So 1 into what is the machine powered time, that is something around 0.30. So 0.30. So this will be the normal time, and it is something around 2.22 minutes. So hope the idea is clear. You are just considering 2 elements here, that is element number 2, element number 5 and element number 8, and you are just finding out the rating of element number 2, 5 with respect to what value? The PMTS time value, which you already know, and you find out the normal time of the entire system. Hope the idea is clear. Now we will go to the next rating system, that is called the Westinghouse system of rating. Westinghouse system of rating usually has 4 factors. So what are the 4 factors? It is the skills involved, it is the effort, it is the conditions and consistency. So these are the 4 factors which are involved when you consider Westinghouse system of rating. So these 4 conditions can again be subdivided into 6 classes. For example, the skill factor, for example, if you take the skill can be poor skill, it can be fair skill, average skill, good skill, excellent skill, and super skill. Okay, so again, these 6 classes can be divided into 2 degrees, and the degrees are rated in terms of 1 or 2. That is, poor degree 1, say for example P1, yeah, and fair F1, etc. Similarly, poor degree 2 and fair degree 2. So this is how you classify. And this particular skill set is equivalent, as equivalent percentage value of each class of skill is provided in the table. So what is there? There is a table, there is a standard table, and there is a rating which ranges from plus 15% to minus 22%. So you have a standard table to look into, and you can find out the rating given in between plus 15% to minus 22%. So if you have a rating of plus 15%, that means that you are having a super skill of higher degree, and if you are having a minus 22 degree, that means you are having a poor skill of lower degree. Now we'll go to the table so that the idea is more clear. So in this table, this is the table which I spoke to you just before. This is the standard table, and you have some standard values here. So you have the skill ratings, condition rating, and there is also effort rating which is not shown in this table. Now as of now we just have this 3. So the skill rating, as you can see, it is given as super skill, excellent, good, average, fair, and poor. Okay, and this is also having 2 rating, that is super skill at a higher level and a lower level, excellent skill at a higher level and a lower level. So hope this standard table is clear. Let us take an example. Say if the observed time of an operator is 1.5 minutes, if he is having an observed time of so this is his observed time. Okay, now what an industrial engineer will do is he will analyze his skills, his efforts, his conditions, and his consistency. So after analyzing the skills, the conditions, and the consistency, he will mark, he will give the worker certain marks or certain ratings. Suppose if the worker is having for example good skill, of say higher quality, then you go for C1 and you take the rating value. And what is the value there? That is 0.06, and this plus sign is very important. And now for example say he is having excellent efforts, he is doing excellent efforts. The values for excellency is not shown here, so I'm just assuming the value to be, say I'm just taking it as B2, and I am assuming it to be 0.08. Okay, and say regarding the conditions, if the conditions then is considered to be average, then for average condition, what is the value? The value is D and it is 0. So I just took it as D is equal to 0. Now regarding the consistency, the consistency is say let's assume it to be, what should we assume? We can assume it to be say good. We are just assuming it to be good. So the value is 0.02. So you got all the rating, and then what you will have to do is you will have to sum up all these values. So after summing up, you will get a value that is 0.06 plus 0.08 plus 0.02. So that will be something around 0.16, right? So you got the consistency value, and after you got the consistency value, you have an observed time of 1.50. Okay, that into 1 plus what you got, that is 0.16. So the normal time will be 1.50 into 1.16. So this is how you calculate the normal time if you have Westinghouse system of rating. Hope the idea is clear. To summarize, you are just adding here. I just assumed some values, that is, you considered him to be having good skill and you found out the value. He is having excellent efforts. You assumed the value. The conditions is an average and the consistency is 0.02. The consistency was considered to be good, so you took the value 0.02, you sum it up, so you got the total rating. And after you have the total rating, what do? You add it with 1 and then you multiply with the observed time or the actual time, then you will get the normal time. So you got a standard for doing this particular job. Okay, now let's go to what is meant by objective rating. So this is the last kind of performance rating system. In this system, what you see is the speed of movements and the job difficulty, how difficult the job is to be done, or how what is the difficulty level of doing that particular job. So these two are considered in objective rating, that is the speed of movements and job difficulty. The speed rating you already saw in the first, that was the first kind of performance rating. So it is the same, the idea is the same here. The rating of speed or pace is done as discussed earlier. We already discussed that in the first slide. And the rating of job difficulty is done by selecting adjustment factors corresponding to characteristics of observation with respect to amount of body used, the foot pedals, the bimanualness, that is, if both the hands are used, the eye-hand coordination. So these are all basically related to the movement or the motion of your body, the handling requirements, the weight handled, etc. So if you consider all these factors, you can maybe come to a conclusion about how difficult the job is. Okay, so if you know how difficult the job is and if you know the speed of the movements, then you simply multiply the difficulty factor, the job difficulty factor, with respect to the pace rating factor or the speed factor, and then you get the objective rating factor. So this is how you do the performance rating in the case of objective rating. So hope the idea is clear. Let me know in case of any doubts. Thank you.